Good morning and good afternoon, all. My research is on influence of soil moisture on growth and yield of Chia, Salvia hispanica in Meru County. I'm Moses Njoka, my supervisors are Professor Peter Matinde and Dr. Cynthia Mugo. Chia is also known as Salvia hispanica, a herbaceous plant belonging to the mint family. Is also called the sleeping beauty. In Aztec, it also called the gold of Aztec. Chia has been hailed as a superfood due to its nutritious benefits in terms of having high amount of fiber, high amount of omega-3 fatty acids, and high amount of protein and mineral antioxidants. It has been also explained that it can beneficial in terms of the digestive health, in lowering blood pressure, and reducing the chances of getting obese. Chia can be grown under rain-fed and irrigated fields. In Kenya, we have a large area which is asal area. 80% of Kenya is asal area, and so there's a potential of having both unreliable and unreliable rainfall, which is not consistent. According to this map, we can see that Kenya, the Chia was introduced during the 2010. Any red color you see there, that Chia was introduced in that country during 2010. Canada also, the Chia was introduced in 2010. India also, Chia was introduced in 2010. However, in China, there is no information in regards to Chia introduction. There is limited information on the economic management of Chia in Kenya in terms of the soil and water management. The objective was to determine the influence of soil moisture on the growth and yield of Chia in Meru County, Kenya. The study was conducted in Meru University, which is in Kenya, in the month of March to October 2021. And Chia was subjected to different soil moisture regimes, that is watering in different stages of growth. This was due to the fact that our farmers in Kenya would be planting Chia at different times, and so the rainfall could end at any given point. It could end at seedling stage, it could end at vegetative stage, it could end at flowering stage, whereas also rainfall could prolong throughout the growing period. So this was a replica of what is happening in Kenya. The experiment was placed in a randomized complete block design with the new implications, and the plants were watered 3 times per week to achieve a field capacity of 90-95%. These are some of the few images of the Chia production in Kenya. The first image is where plants are being watered at the seedling stage. Second stage is where plants are being watered vegetative stage, and other plants are not being watered at seedling stage, as you can see in this dry plot here, and other plants are being watered at also mature Chia plants in the field. These were the results that in terms of the leaf number, stem height, and also the stem diameter ratio. The plants maintained higher growth and a plateau during this stage in terms of the leaf number. There was a higher plateau and the water was maintained at about 0.4 gravimetric water ratio. When the water available to the plant reduced to be below 0.6, the plant had a decline in terms of growth, in terms of the leaf number and the stem diameter and the stem height. That is, there was a linear decline in terms of the growth when the water was reduced to the plant. In terms of the Chia seed yield, the plants that were watered to seedling stage had a lower seed yield, getting 11.92 grams per plant, while control plants, those are what plants that were watered throughout the project, had maintained a higher seed yield of 8.15. However, there was no significant differences between those plants that were watered flowering stage and those plants that were watered continuously watered throughout the growing period. In terms of the adults and seed yield, was no differences in terms of the seed size, both in all treatments in terms of the seedling stage, plants watered to vegetative stage, plants watered to flowering stage, and plants continuously watered during the growing period. This was the fact that and the plants had more water, or the water that was provided to the plant was more. It led to vegetative growth. And as you remember that when there is higher vegetative growth in terms of the leaf number, there is higher photosynthetic rate, which optimally leads to higher seed yield. Whereas where there is lower production of the leaves due to technique where the plant try to resist drought, you find that the growth was less and the leaves were produced also less, and this led to reduced yield. These are also some photos of what happened in the field. As you can see, where the plants were not watered at seedling stage, there was high loaching, and the plants fell due to drought, and also there was high seed shattering due to decreased stems. In terms of the vegetative state, the plants matured earlier than plants that were watered to maturity, and this had an effect. With those plants also that were watered to seedling stage, the plants wilted, and some of the plants also had some diseases. In conclusion, is that Chia growth was negatively affected by 20 to 40% decrease in the water available to the plant. And so for higher growth and for higher seed yield, we should maintain our plant above, water should be maintained above 40%. And the best practice that we could recommend to our farmers in Kenya is that we should water to flowering stage for them to have higher yield. Thank you.